Hi, sir.
Okay, let's start our lesson today lah. Okay, take out your physics one. Take out your physics one. Let's start today. Okay, we go into a new chapter already lah. Okay, we go into a new chapter already. It's very important lah. We already finished all about thermal. Now we go into a new chapter. Okay, so for this chapter or for the syllabus, it's about all about wave. Got three. The first one is wave. Second one is mechanical wave, and the third one will be light. Okay, wave, mechanical wave, and light. Okay, for according to the syllabus on UEC exam, here is the syllabus lah. Okay, the first one is oscillation. We learned this last year already. You still remember the oscillation stuff, like for example the 1/2 mv square and 1/2 kn square. Okay, if you forget, it's okay. We already learned it later on. Okay, but today, what we're going to focus is about 4.2.1 and 4.2.2. Apply progressive wave equation and analyze the graph of progression wave. So it's about this one. So before we go into this topic, let's think about question now. So what happens if there is a droplet drop into the water? What happens? Any? Sorry? Okay, so we have water wave lah. So when there's a droplet drop in the water, you have a wave. So what we want to study today is about this. But instead of just the wave, we need to study like if there is a ball on the wave. Okay, so there is a ball on the wave. That means we like want to figure out how the ball moves lah. Okay, according to the wave. Okay, so this is actually what we want to learn in this for today's lesson about progressive wave and something else. Okay, so before that, we also know that the ball will go up and down if there's a wave. When you want to form an equation to show how the ball moves. Okay, so today is about this. Okay, so today's lesson is about wave very easy Okay, so before that we want to learn about wave. There's two types of wave. Okay, there's one called transverse wave. Okay, and the other one is called longitudinal wave. Okay, there's two types of waves. So for today, what we want to learn is only about transverse wave. It's only about transverse wave. So, okay, we will go into detail a bit. What is a transverse wave? Okay, for example, if this is a wave, okay, just now what we talked about is a droplet drop over here, and there is a wave going to the side lah. Okay, so if there is a ball over here, what happens to the ball? Go up and down only, right? So yeah, for a transverse wave, the definition of transverse wave, if the movement of the particle, you treat it as a particle over here, the movement of particle is only up and down, okay? But the wave is moving from left to right. That is a transverse wave. Again, so the particle over here is moving up and down, but the wave progress is going from left to right. So it's actually 90 degrees. So when it is 90 degrees, we call it a transverse wave. Okay? Very easy. Very easy. Okay? We will learn about longitudinal wave later on, but today we will focus on transverse wave. Okay? Transverse wave, there's several criteria. The first one is called, the easier one is called crest and trough. Crest is just the highest point of the wave line. Okay? And trough is the lowest point of the wave. Okay? And here, this here is called amplitude. I think you guys learned before already, like last time. Yeah, this is the amplitude, and this is the wavelength. Wavelength also understand, right? Wavelength also understand. Okay, so I think this part is already we already learned before, but I need to go through slightly. Okay, so wavelength is just from one point to one point, trough to trough, or crest to crest, or you can see from here going up, down, go back here. So this until here to here is also considered as a wavelength. Okay, and this is called a lambda. Very easy. You understand? Is it okay? Okay, it's okay. This is just an introduction of what you want to learn. Okay, the first point. Okay, very easy. Okay, so before we continue the next part, we also need to think about what is time and what is frequency and what is period. Do you guys still remember what is period and what is time? Period and frequency. Still remember? If you call someone to give a definition, what is frequency? Can someone give me? Cannot?
Frequency is the amount of waves going up and down per second.
Okay, so it's actually calculate, for example, for me, I'm moving sideways lah, here lah. Okay, so from here, from the right side, okay, right side to the left side, go back to the right side. Here is one time, one swing, right? So for frequency, just in 1 second, I can go front and back how many times? This is just frequency. And how about period? Period is just for one time using how many seconds? Okay, one time using how many seconds? Okay, so there's a big difference between T, big T, capital letter T, and small t. Okay, capital letter T is a period, small t is what you want to find. Okay, capital letter T is what is the period, and small t is what you want to find. So here is using T, the capital letter T, so it's about period. So going up now, come back to the original point, place using how many seconds? Okay. And because of that, okay, sorry, someone is writing down. It's okay. Okay. So hopefully, because we're going to new lesson already, last exam very bad, right? This lesson, start to focus already, no time to play anymore. Okay. Okay. If you copy already, so the next part is this one. So if the wave speed, calculate speed, very simple. So we know that speed v equals to distance over time. So if I have frequency means 1 over t, so I can just put it in. So d and the d is a wavelength. Okay. So because df is just one cycle, and this lambda is also 1. So you can just plug it in and you can get v equals f lambda. Okay, very simple. Okay, I won't go into detail for this one. I won't go detail on this one. Okay, because we have still some more important stuff to do. Is it okay? If you want to write it down, you can write it down first. Okay, we will focus on this next time. Okay, today is not. Today we are focusing on progressive wave and how to predict the wave movement of wave or the movement of a certain part. Later I will just tell you. Okay, is it okay? No issue? No issue? Okay, good. Okay, so this one is okay. Okay, so what you want to learn is this. Okay, this is the important part you want to learn today. Okay, so if you look over here, this is a wave equation. So what is actually a wave equation? Okay, I'm drawing over here. Okay, what is a wave equation? So for example, this is a y, this is an x. Okay, so this is an xy graph, xy graph. So if I draw like this, so this is actually how we saw the wave. Okay, this x and this y, focusing on x and y. So if there's a droplet drop over here, we can see the wave progression like this. Is it simple? Okay, so this we want to write it in equation form. Okay, so there's two. The first one is this. Okay, a cos 2 pi x over lambda. This one is another a cos 2 pi x over. This one is wrong already lah. This one is a plain t lah. Okay, this t lah. Okay, 2 pi t over a period. Okay, so this one is focusing on the position, and here is focusing on time. Okay, here is focusing on the position, here is focusing on the time. Okay, later I explain. For example, I'm using this one. Okay, using this one. Okay. For here, we need to look is y equals a cos 2 pi x over lambda. Okay. So what is the first thing? Y. So this equation is about understanding what is the height of the wave or the certain position. For example, if I put in here and I find this point, so this is the height, so this is the y. Understand? For example, the maximum height over here that I give the number 10. So maybe here is 5. So here is 5. Understand? So this equation, the purpose of this equation is just to find the amplitude, not the amplitude, the height of the wave. Okay, the height of the wave. Okay, it's important for us to understand what is actually mean in this equation, not just substitute, find answer, substitute, find answer, put it in, find answer now. You want to understand one by one what is meaning lah. Okay? So if you look over here, if I say y equals a cos 0 lah, cos plus 0, it's not cos square is not like this, sorry. Give a proper graph, cos square is like this. Okay, this is a cos graph lah. Okay? So if I write y equals a cos 0, so what is the height? A, okay, because cos 0 is a man. So this is the maximum point like this one. Understand? So what is actually this show is just what in this wavelength, in this wavelength, what section is this? For example, fx lah. So okay, for example, this is just a wire lah. For example, wire. Okay. For example, this is a wire. The wire. Okay, the wire for a lambda. Okay, the lambda is over here. Okay. So for example, I'm asking, what happens if I reach until half lambda, 1/2 lambda? What happens? Okay, what is the height of half lambda? Okay, maybe it is let's go back here, half lambda. So it's this position, because this is 1, here is half lah, here is 1/4. Understand? Here is 1/4. Okay? Okay, 1/4. So if this is half lambda, the position is negative y or negative. So y is actually negative 10 lah. Like this. Is it okay? Is it okay? So for y equals a cos 2 pi x over lambda is governed by we focusing on the position of x. The position of x. But what happens if it's t over period is focusing on time? For example, okay, for this, okay, it's very important when we say this one, okay, what is this time? What is the time period for this one? So if we're using this, we're assuming the time is actually 0. Okay, so at 0, the graph will look like this. Is it okay? Very important, because later we'll mix together. Okay? For this equation, we are assuming the time is 0. Okay? So, 在零秒我拍的时候 so like this one. Is it okay? What happened to this? This is when I assume the position of x is 0. Okay? So, 就是 if I draw over here, later you will get the idea. Okay. For this one, I'm assuming if this is the wire, okay, I'm assuming I'm at this position A. Understand? And what happened to the position? What happened to the wave look like at position A? It will look like this one. Okay, so this wire at this position A, according to the time and y, the particle over here look like this. The particle look like this. Okay, so it's very important what we are assuming. Okay, not just substitute find answer. Okay, because later we'll compare this too. Got any question or not? Okay, you actually can both two graph put together. Okay, you just need to understand what do we mean. For example, if this focusing on this one, y equals a cos 2 pi x over lambda. Okay, you guys know why you want to use this one? Why you know it's 2 pi?
Because it's the circle.
Yeah. So because the circle is 2 pi lah. Like radian lah. Okay, this one we learned before already Okay. For example, if this table, we are looking at this. If here shown is a y-x graph, so it's just showing the line. Why I keep drawing this? Okay. The line. Look, if this position, if I tell you, for example, I find, hey, what is this position? What is the x over here? Or for example, what is the x over here? For example, a, what is a? You can use this formula to find. Don't use a, very confusing. Use alpha lah. Okay, what is alpha? The position of alpha, what is this? You can find out. You can find the height first. Okay, for example, y is this one is 7, so you can say 7 equals 10 cos 2 pi. If the lambda here is maybe 5, okay, 5, then you can find this one is finished. Then you just 7 divided by 10 cos negative 1, then divide by 2 pi, you get then times 5. Okay, question mark? This is very simple. Okay, so this is actually for, if you're using an XY graph, we can determine the at this position, what is this position? Even the height or the position of x. Okay, but what if I don't want this one? I'm using a time y graph. What I mean by this? If I use this equation in this, y and minus. If I use this equation in this, okay, it means that at this position, what is the graph look like? At this position, what is the graph going to look like? Okay, according to time. Understand? According to time. So there's actually link between two lah. Okay, later on we will learn that. Okay, so this is a simple one. We will continue further on. Okay. Okay, another one. Still got another one. Okay. So if okay, so I change it. Don't use this one xy. Using t and e. Okay. So if this one, you can just at the time where the graph is look like one lah. Very simple. Okay. 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 Again, no. If this one is according to time, we look at the position, at here, this position, this graph, this position, this particle will look like this according to time. But what happens if I change to x and y? Okay, so it means by at that time, x plus y is. So you need to link between two lah. You can have these four different type one. Understand now? You need to think what is the meaning of that? What's the meaning of that? Again, go back to here. For if this is the equation, you need to understand what it means by that now. So at this equation, I'm actually assuming the time is actually 0, and at least I'm assuming the x position is 0. Understand? Later we'll further on. This is very important stuff. 这个很重要这个很重要。Okay, you got that? Okay. Any question? No? Okay, no one. Okay. Let's do some easy question first, then we go to the application. Okay. Can see or not? Cannot okay. Try and do this question. Very easy, The first one is just to write it down if you are not seeing clearly. Okay, very simple. Okay, what is the answer? What is A? Okay, very simple. A is file because this graph is actually look like this. Y equals A cos 2 pi or x over lambda. So A is how many? A is 5. Lambda is how many? 4. Okay, these are very simple only. Okay, the second one? 0.5. Okay, the period will be 0.5, the frequency? 2. Why?
1 over 0.5.
Yeah, very simple. F equals to 1 over t. I say t is 0.5, right? Then t is F is equal to 0. And the unit is Hertz, don't forget, last time we did before. No issue? No issue, right? Later I teach much harder stuff. And do last one. Okay, what is the difference compared to 2 sine 2 pi x over 6 and 2 cos 2 pi x over 6? What is the difference between that? Okay, so over here is we look very difficult, it's actually very easy. So you see sine and cos, it's just the how the wave look like is different only lah. So if 2 cos, the wave is like this one. 2 sine, the wave is look like this one. Just different like this only lah. What is the wave look like at position or time? Is it time? No, as position lah. So different only lah. So this one is sine, this one is cos lah. Okay, just like this. Okay, very simple. Okay, now I want to teach the difficult part lah. Okay, oh, very difficult. Okay. Okay. So now I want to combine 2 together. Combine 2 together, for example. Okay, this is y, this is x. Okay, so this graph, if it look like this, okay, I can say this is a y, a cos 2 pi x over lambda. Okay, very simple lah. So this equation, wave equation is look like this. So what happens if I want to find 5 seconds or 2 seconds later? How should I draw? If 2 seconds later, or not 2 seconds later lah. Okay. If I want to find half a period later, how should I draw? So if I want to find half a period later, what is this? Okay, what is this going? If this one moving forward lah, it will look like what? It will look like this, right? Like maybe like this. Is it? Because this is moving forward, right? Okay. Then continue. I got another color, so you look more clearly. So it will be like this. Okay. Oh, wait, it's not already color. It's okay lah. Okay. You're moving forward like this, right? You're moving forward like this, right? Okay, so how's that block? Okay, so if moving forward like this, okay, if moving forward like this, how should I write over here? How should I write? Okay, how should I write? Can think or not? You have any idea?
Sine.
No lah, it's full cos lah. I just change this one. I just change the equation a bit. So if y equals to a cos 2 pi x over lambda. Okay, I just add something over here. I just add something inside here. Okay. For example, if I'm moving here, I need to 加，好吗？For example, degree 啦， degree 给一个 degree 吧，90，对吧？如果以之前的话 if I'm moving forward, is it? Can you calculate for me? Sometimes, right? Okay, assume this is 0 lah. Assume this is 0 and 90 会怎样 ？Okay. Okay, 怎样？你去中间。You just assume lah, if y, this one is a number lah, for example 1 cos 0 plus 90, it will be at 0. But what happens if this one is not 0, it's 90 degree? What will be the answer? 1 cos 90 plus 90. What does it look like? Huh? -1. So if 我在这边的时候，我应该是 -1， 是吗？我在这边的时候应该是 -1吗？So for example, if this is positive, 我要放的是不是要放 negative？ Okay. For example, if 我走过去这边，我要放的是哪个地？如果我走过去这边，我要放的是这边，不要在这边。OK。所以如果我走更多，我要放。如果你算好来了。Okay. So actually for this one we will look like this. 如果 according to time will be 2 pi P over okay. Negative and positive is just moving left or right only. You can calculate yourself lah. Okay, moving left or right only. Positive or negative.
Why negative?
You calculate lah.
Why this direction negative?
Why this direct negative part? For example, this is starting forward. Y moving here. Okay. Why this one moving forward? Your negative part. Because this one is go back further right. 我们从这里开始吗？你看移啊，不是去前面了没？就从这里开始嘛，所以我是算回去。你看啊 ，my graph over here is moving forward. It will be look like the red color one, right? So this is actually here, right? The previous part. Here, if here move forward, it will be the red color one. Here move forward, the white move forward will be red color one. So the white previously is like this, right? So this part will move forward. So it's like this, right? Okay. So the 加减 is just based on how you move for it, if I'm not mistaken. Okay? Is it okay? So the y order is this one. Okay? It's just based on the height, the length of the wave or which section. Okay? For example, you want to calculate this one at this position A, you can 想象这里有一个 particle, or you can think here there's a particle over here. What will it look like? Then 你要自己想based on this one. Two combine together according to time or according to the position differently. Okay, later we'll do more lah. We'll do more specific. Okay, macam go to the first. Okay, do a simple one. Okay, one back. Okay. This one, difficult. Okay, can someone sketch for me? Okay, because no motivation, right? 那个3块7是这个来的。Oh one food， 不要我第四啦。Okay， 快点吧。faster 吧 ，faster。来啦。1 2。faster 啦，停啦。Okay。State the wave or this one didn't state clearly lah. I want the wave is looking like XY graph lah. XY graph. Okay, XY graph. Okay. If you put the value over here, it should be using what you call we were using gradient form lah. If y equals 4 cos, okay, 2 pi x over lambda, okay, plus 2 pi e over 2. Okay, so this one is 1, so you will look like this one. Okay, so it's moving 一个摆啦，一个盘。Okay, so when you stretch this one, so if this one is actually look like this, right? The 4 cos 1 start from 4 嘛 Start from 4 and end in negative 4 ma. Okay, I draw this one first, no pi. Draw this one first. Okay, it will look like this. Okay, and go back here is how long? Is 8 lah. So here is, for example, if 8 meter, here is 8 meter lah. Not nice lah. Here is 8 meter. For example 8. Okay, but 加移回来吧，所以你要一个排，所以这个点就在这边。So it will look like this. Okay, it will look like this. Understand? 移回来，移回来。See here moving here, here moving here. Okay, so this is how we draw. Understand or not? Okay, so starting you will be confused, but you draw this first, then you move by how to move. 加 move back 减 is okay 啊 is it okay is it okay okay 下一题不要different啦different啦不要give another question 啦 don't do this one give another question okay okay who solve it 我请他吃饼干啦 okay you don't want with me 咯 okay Okay. Okay. Okay, ba? After draw, I got 6 only. Which draw? How about draw? Okay, ba? Lucas. Come here. Okay, ba? Draw ba? Okay. 6 6 draw ba? Okay, later still got another question. Okay. Draw nicely. Everything need to label. Everything need to label. Okay. Don't be afraid. Okay. Green. Green 要吗？来拿。来拿。Okay,有人拍照。Okay, can someone draw? No cheating. Okay. Thank you for 你先换一个字。你用给。 Okay, so this is the answer lah, but miss a lot of stuff lah, miss a lot of stuff. Oi. Okay, this one labeling is important so y, x okay, this, what is this point? What is this point? This point actually what? Height is what?
Eight.
Height is actually 10. Okay, what is 10? Okay, labeling is very important Okay, labeling is very important. So look at here So here is actually y cos. Okay, 2 this. And here is actually sun. Okay. Yeah. Okay, jangan. Okay, so actually moving backwards sun over pi. It's also same as moving forward e over pi. It's also same as negative 1 over 2 pi. Exactly the same. Because maximum 2 pi only maximum also 2 pi only Okay, 因为2 pi 的话就重新来过嘛。If moving forward 3 over 4就是 moving backward 1 over 2 is the same thing. Okay? Is it okay? So this is how we then we draw this one, then we only draw this one So we moving forward 1 over 2. Okay? Okay. So conclusion for today, what we learn. Okay, what we learn today. Okay, very basic stuff. Okay, we learn about. Okay, if this is a wave. Okay, we learn about this is the amplitude. Okay, actually this is just a revision And here to here is a wavelength. Okay, if frequency is 1 over t, frequency is just how many cycles per second, and period is how 1 cycle, how many seconds. Okay, we also learn about V equals to F lambda. Using just revision is not what we learned today. Okay, what we learned today is this two. Okay, y equals a cos 2 pi x over lambda, and another one is a cos 2 pi t over period. Okay, and combination of those will be just like this. Okay, and how the graph will be look like. Is it okay? Okay, 大家呗。今天到这边了我会去。